Fine. Let's start it now. So from today we are going to start BGP, Border Gateway Protocol, right? Very first thing that you must remember or you must know that why do we require BGP? Why it is different from other routing protocols? In which conditions we can implement BGP or we should implement BGP? In which conditions we should not implement BGP in our network? Right? So if you take an example of IGPs such as RIP, EIGRP, OSPF, ISIS, all these protocols are known as IGPs. If you are remember, then in EIGRP it was never possible to form neighborship if they were in different ASs. It was never possible to form EIGRP neighborship between those two devices, right? If you take an example of OSPF, let's say here, because in OSPF there is no concept of AS number. In OSPF we are having the concept of area IDs. Here if you are running area 0 and here if you are running area 1, was it possible for OSPF to form neighborship then? Tell me? Never, right? In OSPF it was mandatory to have same area IDs on both ends in a single segment. In EIGRP it was mandatory to have same ASs on both ends in a single segment, right, to form neighborship. And these things were mandatory. Fine. Apart from that, we saw in EIGRP, or even I taught you during EIGRP, that in EIGRP you cannot have like millions of routes. You cannot have millions of routes. Actually, when they developed these IGPs, whether it is any protocol from IGP like RIP or EIGRP or OSPF or ISIS, they developed these routing protocols to handle up to 1,000 of routes, up to 1,000 of routes, not more than that. So if you are having like up to 1,000 of routes in your network, then you can implement like EIGRP or OSPF. But if you are having more than 1,000 prefixes in your network, then you cannot. I mean, in that case, their algorithm is not supported. Like the algorithm of EIGRP and OSPF will not support more than 1,000 of prefixes. If you are having more than 1,000 of prefixes in your routing table, and you are running either EIGRP or OSPF or any other routing protocol, right? In that case, might be your routing table would be crashed. So routing table of routers can crash in case if you are having more than 1,000 of prefixes in their routing table. I mean, I'm talking in perspective of IGPs only, right? So we cannot have more than 1,000 of prefixes in the routing table of IGPs. Yes, if you talk about convergence, convergence is fast in IGPs, right? As you know that in EIGRP or in OSP, whenever you will make any change, it will be immediately propagated throughout the network. So convergence is fast. There is no problem related to convergence in these IGPs. Even in RIP also, if you make any change, then it will be propagated immediately in your network. Like if you are adding a new network into RIP, or if you are removing a network from RIP domain, then it will be propagated throughout the network immediately, right? But I mean, overall in IGP convergence is good. I mean, convergence is fast, but the problem was that they cannot handle more than 1,000 of prefixes in their routing table. And in EIGRP it is mandatory to have same ASs. In OSPF it is mandatory to have same areas. Now the point is that if you are taking an example of ISP or internet routing table, right, in today's network, in internet routing table, we are having like around 4 million routes, right? Currently we are having around 4 million route available in the routing table of internet. That is also called global BGP table. Global BGP table. So in global BGP table, we are having around 4 million route. So that much number of prefixes cannot be handled by any IGP in their routing table, right? And of course, if you look at either RAP, EICRP or OSPF, they are not fully reliable. Even if you take an example of EICRP and OSPF as well, then they are not fully secure. Or you can say they are not fully reliable. They are not completely reliable. However, in EICRP and OSPF, we are having concept of an acknowledgement, right? Like whenever you will send any information to your neighbor, then it is mandatory to receive an acknowledgement, right? Like in EICRP, if you are giving either update packet or query or reply, whatever it is, right? I mean, in EICRP, for 3 types of packets, we are having this concept of an acknowledgement. In OSPF, again, we are having an acknowledgement for LSU, link state update, right? So point is that although we are having an the external acknowledgement for EICRP and OSPF, but still they are not fully reliable, right? They are not fully. I'm talking about fully reliability, right? So these protocols are not fully reliable. So we were required a routing protocol which could handle like unlimited, or you can say millions of routes in their routing table, right? Reliable, secure. So all these things were required in a single protocol. And at that moment, convergence was not a big deal. They put convergence in a side and they wanted to to make a protocol which could provide you reliability, security, and of course along with that you should be able to install millions of routes in its routing table, right? So finally they launched a protocol that was known as EGP. First of all, EGP came into the market, right? And EGP is what? Exterior gateway protocol. But it was not having so many features in it. Some limited features were available in EGP, right? Exterior gateway protocol. So finally BGP, right? BGP came, and BGP is a extended version of EGP itself. So BGP is what? Border gateway protocol, right? Even in BGP itself, they have launched multiple versions. Like right now we are using version 4, but before that they launched like version 2, version 3. All these versions were available in BGP. I mean, after EGP they launched BGP, and in BGP itself they have launched multiple versions till now, and currently we are using BGP version 4, and we are using this BGP version 4 for IPv4 as well as for IPv6. Right? So now if you talk about ASs, right? All of you know very well that what is an AS, right? Autonomous system. A collection of routers or network devices under a single administration, under a common administration, right, is called one AS. And previously they were represented by 16 bits, means that range was from 0 to 65535. We cannot use 0 and 65535, right? So these are reserved actually. So you can start from 1 and 64511 65534. These are private ASs, and from 1 to 655, sorry, yes, 65 64, yes, 64511. These all ASs are public AS, and in BGP these all ASs are known as private AS. Right? So public AS and private AS, I mean the differences in between public and private AS is same as public and private IP addresses. Like in global routing table, your prefixes with private AS will not be allowed. Internet will never allow prefixes with private ASs. Right? However, your provider, like for an example, I have taken connection from Airtel. Then of course Airtel has to accept my prefixes with private AS. But whenever Airtel will forward those prefixes towards any other ISP, then it has to remove private AS before forwarding our routes towards any other ISP. But at least Airtel has to accept prefixes coming with private AS. Fine. Nowadays they have made some changes in ASs as well. Now they are having 32 bits long ASs. Right? So in case of 32 bits long ASs, now you can represent it from 0 to 4.2 billions. You can take any number, right? And you can also represent your AS in this format as well, 16 bits dot 16 bits, like 0 to 65535 dot 0 to 65535 in this manner as well. Like 1.1, 1.10 or 50.50, something like that. Right? So you can also represent your ASs in BGP in this format as well. So it's up to you whether you want to use 16 bits long ASs or 32 bits long ASs. It is also possible, let's say on R1 and on R2 you are using here 16 bits long AS and here you are using 32 bits long AS, but still they can form neighborship. Clear? Fine. See, now let's talk about that. Okay, we have came to know that okay, BGP is the protocol which can handle up to millions of routes in its routing table, and it is completely reliable as well, right? Completely reliable protocol. But always remember that it does not have fast convergence, right? Remember that BGP does not have fast convergence as compared to like IGPs, right? ICPs are very, I mean, they are having very fast convergence as compared to BGP, right? So we will never compare convergence in between ICPs and BGP. Of course, BGP has slow convergence, right? Fine. But it is a completely reliable protocol. You must remember, right? You know why? Because it will always use TCP port number 179. BGP does not use either UDP or IP protocol number, right? It has TCP port number, I mean IP protocol number. It uses TCP port number 179, which means that whenever you will try to form BGP peering in between two routers, first of all, TCP connection will be formed between those two devices, right? So first of all, they will form TCP connection, and then only they can send any information related to BGP. Like all types of messages in BGP will be forwarded over TCP connection, right? If TCP connection doesn't come up, in that case BGP will never send any single packet. So very first requirement in BGP is to form TCP connection, is to perform three-way handshaking, right? And then only BGP can send any type of message. In BGP we are having various types of messages. I'll be discussing all those types of messages later on, but right now you must remember that all types of messages in BGP will be forwarded over TCP connection only. If TCP connection does not come up successfully, I mean doesn't come up successfully, then definitely it will not be possible for BGP to forward any type of packet or towards its neighbor. That's why we are calling it as a fully reliable as well as secure, because in BGP we can also configure password for its neighbor, right? And of course we are using TCP, so we can also call it a completely secure and reliable protocol. Fine. Why do we need to configure BGP? Where we can configure BGP? See, if you are a customer, let's say CE router is connected with an ISP, would you recommend to configure BGP in between customer and ISP? No. You know why? Because instead of configuring BGP, you can simply configure a default route in the direction of ISP, and along with that configure NAT. There will not be any problem. You can still access an internet, right? And if you try to configure BGP now at the end of customer edge router, then you know what will happen. Now here you have to buy a router which can install like millions of routes in its routing table. Then you have to hire an employee who can configure BGP, who can manage BGP in well manner, right? Who knows BGP well. So, and you know, if I do not configure BGP, then I'll buy one small modem. I'll configure a default route in the direction of ISP, will configure NAT, and will start accessing internet. So of course we will never go for BGP in such kind of scenarios, right? Clear? But in case if you are an ISP itself, like I am ISP, right? Within an ISP also you will find some routers configured over there, right? So if some routers are existing within the ISP's ISP network, then of course you do not have any other option apart from BGP. Because as I told you before, that in global BGP table currently we are having approximately 4 million routes. So in that case it will be mandatory for you to configure only and only BGP. So very first thing is what? If you are an ISP, then it is mandatory to configure BGP. Second, in case let's say this is CE1 and this is what? CE2, or on CE1 itself, like we are having now two internet connections. two different internet connections. Then you will be configuring two default routes, right? And now there is a rule that if your router is having two different default route, but it cannot perform load balancing. A router cannot perform load balancing for default route. It is not possible, right? So if you are having redundant internet connection and if you are using default routing, then it will not be possible for you to achieve load balancing. To get that, it is mandatory, or it will be mandatory, to configure BGP in between customer and ISP. Then again you have to configure BGP. You do not have any other option available except PBR. Yes, you can configure PBR, but that's different thing, right? Policy based routing. I hope that you are remember that what is the meaning by policy based routing, and I think we covered this policy based routing during EICRP. Like, I formed a routing loop with the help of PBR, right? So you can achieve it with the help of PBR, but like with the help of default routing only, it is not possible to get load balancing, right? So to get load balancing, it will be mandatory for you to configure BGP, because you cannot configure any other routing protocol in place of BGP here in between ISP and customer. Because if you try to configure OSPF, EICRP or any other ICP, then it will not be possible for those ICPs to handle that much number of routes in their routing table. So in that case, you will be having only one option to configure, that is BGP. Done? Fine. So if you are having, see, very first condition was that if you are an ISP, then you will require to configure BGP. Second, if you are having redundant internet connection, like if customer is having redundant internet connection, then also you can implement BGP. Third condition is, like, we are having an enterprise network for our organization, right? Big organization is there, and we are having a huge number of prefixes, right? Our organization is huge organization, then also we can go for BGP within the organization as well, right? But make sure that you are having a huge number of prefixes over there. So if you are having a huge number of prefixes, you understand, huge number of prefixes available in in your infrastructure, in your organization, then also you can go for BGP, border gateway protocol, right? And BGP is one of the most flexible protocol among all routing protocols. Like whatever you want to achieve, you can achieve it in BGP very easily, right? It is most flexible protocol among all. Fine. Apart from that, now let's talk about that in BGP, message types. We must be having this information that how many types of messages are available in BGP. Like if you talk about BGP, in BGP you will be having multiple types of messages such as open, keep alive, update, and notification, right? And finally you will be having another message is also there. However, in books you will always find open, keep alive, update, and notification. But one another type of message is also there, that is called route refresh message. Route refresh message. Like for an example, I want to force my neighbor to retransmit all the updates, right? So we can send a route refresh message towards my neighbor, and so that neighbor will retransmit all the updates, right? So that is the uses of route refresh message, right? But mainly these four types of messages are available in BGP: open, keep alive, update, and notification, right? So here, if you take an example, either open or keep alive. Both of them are same as hello in IGPs, whether it was EIGRP or OSPF. These two types of messages in BGP work same as hello does in IGPs. Right? So if you talk about the open packet, let's start with open. First of all, BGP sends open message to each other, right? Like if let's say we implemented BGP on two routers, so before forming neighborship they will send open messages to each other. And in open messages, if you talk about the contents of open message, it will be having version, router ID, hold time, and of course it's on AS, and some other capabilities are also there, right? Some other capabilities will be kept by open message itself. But these are the main components of open packet, like version. So right now we are using version 4. Router ID, you know very well that how will it pick its router ID? It is same as OSPF. And hold down timer, by default 180 seconds. On AS, it's on AS information, right? That what is my AS, right? So in place of on AS you can also say my AS. So these are the components of open packet. Once let's say that they have exchanged their open packet with each other, right? And now they are agree to form neighborship. Then they will start sending keep alive messages in every 60 seconds. And keep alive messages will be used in BGP just to inform its neighbor that I am still alive. Keep alive messages will be used by BGP just to indicate that neighbor is still alive, or I am still alive, do not break neighborship with me, right? Because by default your hold down interval is 180 seconds and keep alive interval is what, 60 seconds. And one more thing, that BGP will never generate any keep alive without without negotiating all the components which are required to form neighborship. If anything mismatches in open message, open packet itself, then it will never generate any keep alive message. So BGP will start generating keep alive message after negotiating all the components of open packet, right? Fine. So keep alive interval is by default 60 seconds. That's it. Then let's talk about the update packet. In BGP, update packet has mainly two components. One, BGP attributes. Second, NLRI. If you talk about NLRI, NLRI is stand for network layer reachability information. BGP attributes and NLRI, right? So BGP attributes, I hope that most of you people are aware with the BGP attributes, as you learned this BGP during CCNP as well. Like we have local preference, AS path, and all these things, right? I mean, BGP attributes are those criterias used by BGP for best path selection. BGP attributes are those criterias which are used by BGP for its best path selection. Right? So update will be carrying first BGP attributes, second NLRI, network layer reachability information. Any problem? You know, BGP does not consume too much bandwidth during updates. I mean during generating updates. You know why? You know, see, if we are saying that BGP can have like millions of routes in its routing table, fine, true. If BGP is having millions of routes in its BGP table, and let's say neighborship came up, or I mean went down and again it is coming up, right? So at that moment it will require to give all the updates, I mean all prefixes information to its neighbor, fine. If it is sending millions of prefixes, and along with those prefixes it has to send BGP attributes as well, so during updation might be your entire available bandwidth will be chalk, is not it? So to prevent from that problem, in BGP we are having this concept that it will be having BGP attribute and NLRI. There are two different things, right? BGP attributes and NLRI. See, what does it do actually? Let's say there are 100 prefixes and all of them are having same attributes. So what will it do? Under BGP attributes it will specify all those attributes, and under those attributes it will specify NLRI. Under NLRI it will specify all those 100 prefixes. In BGP it does not add BGP attribute per prefix basis, and that was happening during IGPs. We saw over there that when we open route in BGP, sorry, in other routing protocols like in OSP or DICRP, like we said, show IP ICRP topology 10.1.1.0/24, whatever it was, right? So we opened that and we saw that all those metric components were attached to each prefix individually, right? All the metric calculation components were attached to each prefix individually, right? But here in BGP it will never happen. In BGP, if your 1000 prefixes are having same attributes, it will create a single table under, I mean in BGP attributes, right? And under BGP attributes it will define NLRI, and under NLRI it will be having all those prefixes, all those 1000 prefixes which are having same attributes. So here in BGP is not gonna to attach all the BGP attributes per prefix basis. If BGP is having, yes, it is also possible that for each prefix you are having different attributes, right? Then again BGP will also behave like ICPs, but it will not happen. Don't worry about that. It will never be, it will never happen that okay, for each prefix you are having different attributes. Of course you will be having some group of prefixes, for them you will be having same attributes, right? So in BGP, BGP is not gonna to attach attributes for, in each prefix, individually, in each route individually. It will never happen. Is there any problem? Sure. So I hope that you people have understood the meaning by, or the concept behind BGP attributes and NLRI, and that is why it will not consume too much network bandwidth during BGP updates. It is conserving network bandwidth by doing this. Any problem? Fine. Finally, notification. When BGP neighborship will go down, like let's say that your hold down timer has got expired, so now your BGP peering will go down. So before terminating BGP peering, it will send a notification to its peer that okay, I am terminating, or I am tearing down this BGP peering due to this reason. That's called notification. So remember that whenever hold down timer will about to expire, so before tearing down BGP peering, BGP neighborship, it will generate a notification message towards its peer that I am tearing down this BGP neighborship, this BGP peering due to this region. Understood? So this is the uses of notification message in BGP. Fine. Now, in BGP we have some types of customers. I hope that you heard about them during CCNP as well. Types of customers. Like you are having single homed customer, single, multi-homed, dual multi-homed. Right? Dual multi-homed. So these types of customers are actually can be there. So accordingly you have to decide that whether to implement BGP or not, right? So if you are having single homed, meaning, what is the meaning by single homed? There will be one ISP and one customer edge router. So this is your single homed customer. Right? If you are having single homed customer, you will always prefer, tell me, default route. You will always configure a static default route in the direction of ISP, and you can configure netting, you can further configure netting just to access an internet, right? Then after you are also having dual homed. In dual homed you will be having internet connection, another internet connection, but from same ISP. That is called dual homed customer. If your customer is having multiple connections, at least two connections from same ISP, that will be called, or that will be known as dual homed customer. If you are having dual homed, now you can think about BGP. Because in case if you are using static default routing, then you won't be able to get load balancing, right? Then you can also have single multi-homed. Wherever you will be having multi-homed, which means that you will be having multiple ISPs. So in case of single multi-homed, you will be having at least two ISPs. So let's say this is your ISP1 and this is your ISP2, and this is your customer edge router, and this customer edge router will be having connections from both ISPs, at least one connection, right? So this type of customer will be known as single multi-homed customer. At least two ISPs and at least one internet connection from each ISP, right? So that is called single multi-homed customer. Then you are also having, in case of single multi-homed, again you will require to configure BGP, right? Apart from it, you are also having dual multi-homed. If you are having dual multi-homed, which means that you will again require to have at least two ISPs, and from each ISP you have to take at least two internet connections. So this time I'll be taking at least two customer edge router. This is CE1, this is CE2, and further they are interconnected, right? And then they took connection from ISP1, ISP2, and similarly over here, right? So this time this customer will be known as dual multi-homed customer. This type of customer will always be known as dual multi-homed customer. Right? So again you will require to implement BGP in such scenarios. Fine. BGP, right? CIDR, summarization. You must be having this knowledge that how to perform summarization and all. Classless routing, I have already told you. We could also implement OSPF, right? Like in this manner. You know, we have NAP. NAP is, I think, NAP is called network access points, and all these NAPs, network access points, like all of them are in US, and these are maintained by like Sprint, Pacific Bell, ICS, MCI, WorldCom.
इंडिया में नहीं है,
नो, नैप नहीं है।
इंडिया में क्या है?
इंडिया में क्या है?
यानी कि जैसे सर्विस प्रोवाइडर है,
हाँ,
एयरटेल है, टाटा है,
ठीक है। सो देन let's talk about BGP itself. तो अभी तो इसमें देखो वही है कि ये who needs BGPC, you could implement OSPF as well, like OSPF1, global backbone, and you know, configure virtual link and all, and all companies could connect together with the help of OSPF as well. But As you know that OSPF cannot handle more than 1000 of prefixes, right? So in that case you have only one option, that is BGP. So you will be implementing BGP. This is called single homed autonomous system, right? This single homed customer, one ISP, one link, fine. Then multi-homing to a single autonomous system. So all these things that we discussed till now, multi-homing to multiple autonomous systems. So BGP basics. Now BGP has started. As I told you that BGP will be using TCP port number 179, so it will be completely secure, completely reliable, right? And it is also called it is also known as path vector routing protocol. But you know why do we call it as path vector routing protocol? Because of it uses AS path attribute for its path best path selection, right? That is why we will call it path vector routing protocol. But in actual, it is a distance vector routing protocol. In actual, BGP is also a distance vector routing protocol. You know why? Because BGP will also advertise only that information, or you can say only best information towards its neighbor. Means it is not like link state routing protocols, right? It will not maintain a complete or full database table, right? It will not maintain a complete database table. So BGP will also work same as distance vector routing protocols, like it will also advertise only and only best path information, right? So now you can see fine. BGP message types, as I just told you, open, keep alive, update, notification. All types of BGP messages will be forwarded over TCP connection. Open message like BGP version, right? 2, 3 or 4. So currently we are using version 4. Then autonomous system number means its AS number will be held by open message itself, right? Hold down timer, which is by default 180 seconds. BGP identifier, which is your router ID. Some optional parameters will also be given within the open message. This field is used to advertise support for such optional capabilities as authentication, multi-protocol support, or route refresh. So all that information will be under optional parameters. Keep alive message. If a router accepts the parameters specified in its neighbors open message, as I told you that if they are agreed on all parameters of the given in open messages, so in that case it will start sending keep alive messages to each other. Neighbors will start sending keep alive messages to each other so that they can confirm to each other that they are still alive, right? So for and keep alive interval will be by default 60 seconds in on by Cisco by default, right? And and it will always be 1/3 the it should be it is by default equal to 1/3 of hold down time. Update message, as I told you, NLRI path attributes. Okay, in update message it can also have withdrawn route. I actually skipped this point, or I forgot this point. Withdrawn routes. Do you understand the meaning by withdrawn routes? So let's say that you have removed any route from the BGP table. So now BGP will again give an update to its neighbor, but those prefixes will be listed under withdrawn routes, that these prefixes have been removed. These prefixes have been removed from the BGP, right? So update packet will also contain these withdrawn routes as well. So NLRI is there, path attributes are there. Apart from that, withdrawn routes will also contain by update message. Then after we are also having notification message. As I told you that in case if BGP tear down its neighborship after expiration of hold down interval, then before tearing down its neighborship it will inform to its neighbor by sending notification message that I am tearing down this neighborship due to this reason.
So here in this book it is written that NLRI contains only one route.
Where?
Yeah, not that although
This is one or more.
No, below withdrawn routes. Note that although multiple prefixes might be included in the NLRI field. only a single BGP route. What's the part that is there about a single path? So
Then
means it has a summarized route.
no, it does not have summarize. It is trying to say that okay, if you are having multiple prefixes and for all those prefixes it is having same BGP attributes. Now the point is BGP considers all those prefixes as a single prefix which are having same attributes. You see, not that although multiple prefixes might be included in the NLRI field, each update message describe only a single BGP route because the path attribute describe only a single path, but the path might lead to multiple destinations, right? Which means that it can have multiple prefixes, right? So actually it is trying to say that path attributes will lead to a single path. Now notification message is done, and finally let's talk about FSM in BGP. That is really important in perspective of interview as well. Anyone can ask you that what is FSM of BGP? Finite state mechanism. Machine. Finite state machine, right? And this is neighbor state actually. This is all about neighborship states. So in BGP these are the neighborship states available: ideal, connect, active, open send, open confirm, and established. Right? And this is, this diagram is actually FSM, finite state machine. Means that this diagram or this FSM will tell you that from which state BGP can move in which state and why. So there are some input events 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1 means BGP start, 2 means BGP stop, 3 means BGP transport connection open, 4 means BGP transport connection closed, 5 BGP transport connection open failed, 6 BGP transport fatal error, 7 connect retry timer expired, 8 hold timer expired, 9 keep alive timer expired, 10 receive open message, 11 receive keep alive message, 12 receive update message, 13 receive notification message. Now look at here. Ideal state. If input event 1 occurs, it will move into, means if BGP starts, then it will move into connect state from ideal state. Are you getting my point? If BGP starts, then it will move from ideal to connect state. Now in connect state, input event 2, 4, 6, 8 or 13, 8 to 13, all these events can occur. And if any one of the event occurs like either 2, 4, 6, 8 to 13, it will move back or it will come back from connect to ideal state. What's the meaning by 2? BGP stop. If BGP stops, again it will move back from connect to ideal state. Now once it is in connect state, you must remember that in connect state it will try to establish TCP connection. In connect state it will try to establish TCP connection. Now while it is trying to form TCP connection, there will be only two things: either TCP connection will be formed successfully. If TCP connection forms successfully, if your transport connection is opened successfully, which means input event 3, it will directly move from connect to open sent state. As you can look at here, 3 of BGP transport connection is open. And in case if it gets fail, let's say transport connection was not open successfully, 5, input event 5, BGP transport connection open, failed. So it will move from connect to active state. Means that if your TCP connection was not formed successfully in connect state, then it will move into active state, and it will keep on to try forming TCP connection during active state, right? So in active state, now input event 3 can occur, which means, let's say your TCP connection has formed now successfully, your transport connection has opened now. So from active it will move into open sent state, but you know, from active it can move back into connect state as well. From active state it can also move back to connect state, but in which condition BGP neighborship will move back from active into connect state? There is a timer that is called connect retry timer, that is called connect retry interval, which is by default I think 60 seconds, which is by default 60 seconds, right? So once it has moved into active state, then it will start its connect retry interval, right? Once 60 seconds will get expired, it will move back into connect state and will try to form TCP connection, right? So in case if it's like in active state, if its connect retry timer has got expired, let's say input event 7, connect retry timer expired, right? So if its connect retry timer gets expired, then it will move from active back to connect state, right? Fine. In case if TCP connection was open successfully, then it will move from active into open sent state, right? Which means your TCP connection has formed. Remember, once your BGP neighborship has moved into open sent state, which means TCP connection has formed successfully. Whether it is coming, whether it is coming directly from connected to open sent, or it is coming from active to open sent, in both conditions your TCP connection has established successfully. So if someone asks you that how will you verify in BGP that your TCP connection has established successfully, so you will simply tell that, okay, if BGP neighborship has moved into open sent state, which means that TCP connection has came up successfully, or TCP connection has established successfully, right? So this is the meaning by open sent state. Now in open sent state, input event 10 will occur. Input event 10 will occur, and it means that it has sent open message. If you look at input event 10, look at here, sorry, receive open message. So if it receives open message, it will move into open confirm. And of course in open sent state, we are saying that after receiving open message it will move into open confirm, which means they have to generate open message as well, then only another one can receive open message, right? So they will send open messages, but once anyone, I mean, let's say I have received open message, then immediately I will move into open confirm. See, once your TCP connection will be established, it will send open message to, I mean, they will send open message to each other. Whenever anyone will receive, and they are already in open sent state, right? So whenever they will receive any open message, they will move into open confirm, right? So just after receiving open message, they will move into open confirm state, right? Fine. Then after, in open confirm state, what can you do? That you can input event 2 can occur. 2 means BGP has stopped. It can directly move from open confirm back to ideal state. Similarly, from open sent, it could directly move back into ideal state, right? From open confirm, there are only two conditions. Either it will move into ideal state, or it will move into established state, or it will remain in open confirm state itself. Like this is what? Open confirm state. So if input event 9 occurs, like input event 9 is what? Keep alive timer expired, then also it will remain in open confirm state. Are you getting my point? See, in case if you are in open confirm state and your keep alive timer has got expired, then it will remain in open confirm. So in case if someone asks you during interview that in which condition your neighborship can stuck in open confirm state, then you will simply tell that there will be only two things: either BGP has moved into ideal state, or its keep alive interval has got expired. Then it will remain in open confirm state. Input event 11, it has received or generated, it has received keep alive message. So once In open conform state, it will receive keep alive message. Your neighborship state will be called as established state. It will be established state, right? So this is called FSM, finite state machine in BGP. So in BGP we are having total 6 states: ideal, connect, active, open send, open confirm, and finally established. Ideal state, BGP always begins in ideal state, in which it refuses all incoming connections, right? It will not listen for any it will not listen for BGP connection, right? It will not listen for incoming BGP connections. That is ideal state. And connect retry timer is by default 60 seconds, right? Then connect state, in this state the BGP process is waiting for the TCP connection is to be completed. If the TCP connection is successful, BGP process clears the connect retry timer, completes initialization, and sends an open message to the neighbor and transition to the open send. As I told you that in open send it will send open message, right? So this is the way. If the TCP connection is unsuccessful, then it will BGP process continue to listen for the connection to be initiated by the neighbor, resets the connect retry timer, and transition to the active state, right? Active state. In this state, BGP process is trying to initiate a TCP connection with the neighbor. If the TCP connection is successful, it will BGP process clear the connect retry timer, completes initialization, sends an open message to the neighbor, and transition to open send. And still, if the connection retry timer got expired during active state, then it will move back into connect state and resets the connect retry timer. It also initiates a TCP connection to the peer and continues to listen for connections from the peer. If the neighbor is attempting to establish a TCP session with an unexpected IP address, the connect retry timer is reset and connection is refused. So it will happen during active state. Open sent state, which means you have received an open message has been sent, and BGP is waiting to hear an open from its neighbor. When an open message is received, all its fields are checked. If error exists, a notification message is sent and state transition to ideal. And finally, if no error in received open message, then it will move into open confirm. In open confirm, it will wait for keep alive message. Once it will receive keep alive message, it will move into established state. This is called FSM. Right? Remember, in BGP we have two things. One is called IBGP. There are two flavors available in BGP. One is IBGP, another one is what? EBGP. You know very well that if your neighbor is in same AS100, that in that case for R1 this R2 will be a IBGP. It will be an IBGP neighbor, right? If your neighbor is in different AS, then you will call it that it is an EBGP neighbor. So basically it will be depending on neighbor AS. If if our neighbor is in same AS, then we will call that neighbor as IBGP neighbor, internal BGP. And if our neighbor is in different AS, then we will call that neighbor as EBGP neighbor, right? And it will be depending only on ASs, right? And one more thing, that if you are receiving any prefix from IBGP neighbor, then it will be known as internal prefix, internal route. And if you are receiving any prefix coming from EBGP neighbor, then it will always known as external prefix. It is unlike IGPs, because in IGPs redistributed routes were known as external prefixes, and all those prefixes which were coming from the same AS or from same area, they were known as internal prefixes. Even inter-area prefixes were also called as internal prefixes, but in BGP it will be completely depending only on neighbor. Like if your neighbor is IBGP, then all received prefixes will be known as internal prefixes. If your neighbor is EBGP, then all received prefixes will be known as external prefixes, right? And then after it, let's talk about BGP path attributes as well. BGP path attributes. We are having two types of path attributes in BGP. One is well known, right, and optional. Wait. Well known and optional. Yes. Under well known again, we have two categories: well known, mandatory, and well known, I think discretionary, right? Under optional, transitive, and of course non-transitive. Right? So these are the categories of BGP path attributes: well known, optional, under well known again, mandatory, discretionary, optional, transitive, and non-transitive. First of all, let's try to discuss from path attributes itself. Path attributes are those attributes or are those criteria which are used by BGP to define its best path. Or these attributes are those criteria which will be used by BGP for its best path selection, right? These are categorized into two different categories: well known and optional. Well known means, like in BGP, in most of the cases you will be using them. In most of the cases you will be using them. Optional means if you want to use them, then you can use them, but by default BGP is not going to use them, right? Those attributes will be known as optional attributes. Then under well known, we are having mandatory and discretionary. Mandatory and discretionary. Right? Mandatory, though, I mean well-known mandatory are those attributes which will always carry forward within BGP updates, whether they are going towards IBGP neighbor or EBGP neighbor, whatever it is, doesn't matter. But remember, well-known mandatory attributes will always be carry forward in BGP updates, always. So those attributes will be known as mandatory attributes. Discretionary, sometimes they will go with BGP updates, sometimes they will not go. Sometimes they will go along with BGP updates, sometimes they will not go along with BGP updates. Those attributes will be known as discretionary attributes. I mean those attributes will be known as well-known discretionary attributes. Optional, transitive, non-transitive. Some differences are there. Let's say we have started to use optional attributes. We are sending our updates with using some optional attributes, like we enable them on our router, right? So my neighbor will receive those prefixes with optional attributes. Now your optional attribute will be either transitive or non-transitive. If your optional attribute is transitive, let's say I received one update, BGP update coming with optional attribute, right? I received that, and in received update I found transitive attribute, right? And I don't I don't support that transitive attribute. Let's say I don't support that transitive attribute. So if a receiver does not understand transitive attribute, then it will simply remove that attribute, will accept it, and also will forward it towards another neighbor. Are you getting my point? Let's say I'm having one neighbor, second neighbor, right? I'm having two neighbors. I received updates coming from one of the neighbor with the transitive attributes, and I know that I don't support these attributes. So what will I do? I will remove those. I will remove that attribute from incoming update, will accept it, will install in my BGP table, will define best path, and also will forward towards another neighbor as well. That is the meaning by transitive attribute. And the best example of transitive attribute is your community. In BGP there is a terminology, there is an attribute that is called community. So we will be using this community later on, right? So community is a transitive attribute. Non-transitive, let's say once again I'm having two neighbors, R1 and R2. I received some of the updates coming from R1 with optional non-transitive, and now I came to know that I don't support this attribute. I will not accept those updates. I will simply discard those updates. Receiver will never accept all those updates which are coming with non-transitive, and if receiver does not support those non-transitive attributes, it will simply discard all those incoming updates. Remember, if BGP speaking router is receiving any update with optional non-transitive, and in case if that router does not support that optional non-transitive attribute, then it will simply discard those updates and also will not forward, because that router itself has discarded those incoming updates, so that it will not be possible to forward those updates towards any other neighbor. Because BGP works same as distance vector routing protocol. If there is anything available in its own BGP table as best, then only it will forward that best path information towards its another neighbor, right? So these are the differences in between these things, right? So here we are having so many types of attributes. So under mandatory you will find like next hop. Next hop will always be carried forward within BGP updates. AS path attribute will always be carried forward within BGP updates, whether updates are going towards IBGP or eBGP. Your origin code, this attribute also comes under well-known mandatory. Then under discretionary we are having like local preference, and I think we are also having I think originator ID. Let me check it out, right? Originator ID. I know that you people doesn't understand this originator ID, but I think that is there. Let me show you. No, that is under optional non-transitive. Okay, you can go through this table, right? So here you can see origin code is under well-known mandatory. AS path is also under well-known mandatory. Next hop is also under well-known mandatory. Local preference is also what? Well-known discretionary. Atomic aggregate is kind of summarization, right? This attribute will be used during aggregation in BGP. So atomic aggregate, this attribute will be known as well-known discretionary, and then aggregator is optional transitive. Community is also optional transitive. Then multi-exit discriminator MED is what? Optional non-transitive attribute. Originator ID is also what? Optional non-transitive. Cluster list is also optional non-transitive. There are few more attributes beside the ones listed in this table, right? तो वो उसमें क्या होगा? कि they are neither specified in RFC 1771 or support or nor supported by Cisco, so they are beyond the scope of this book, right? So छोड़ो उनको, बात ही नहीं करेंगे. Fine. So these all attributes are available in BGP, and these are their classes. So in interviews they can ask you that, okay, what is your well-known discretionary attribute in BGP, right?
सर
And
मैड ऑप्शनल नॉन ट्रांजिटिव कैसे होगा?
because you know कैसे हुआ ये तो खैर इन्होंने रखा इस क्लास में, मैं बता देता हूँ ये कैसे आप प्रूव कैसे करोगे. लाइक फॉर एन एग्जांपल, इफ you are not giving your MAD to your eBGP neighbor, then by default it won't go. By default it won't go there. If you configure it, then only it will go. But the point is, if your neighbor doesn't support MED attribute, then it will simply discard your prefixes. But in Cisco devices, it will never happen, because all Cisco devices supports this MED attribute.
So it will not drop it.
Simply, of course, it will not drop all those updates.
So the category should be optional transitive.
But point is, they have given this feature in Cisco devices that it will always support MED. There will be some devices which will not support this attribute, and they will simply discard these updates. Right? Now these are the classes of BGP path attributes. Apart from that, we can discuss that how BGP selects its best path in a sequence, right? How BGP selects its best path. First, it checks next hop reachability. First, it checks next hop reachability. If next hop is not reachable, right? If next hop is not reachable, then it will simply not make that path as a best path, right? Next, after next hop reachability, it will check wait attribute, which is a Cisco proprietary. I will discuss it later on, but it will check wait. Third, local preference. Fourth, self advertised. Fifth, AS path. Then it will compare origin code. Seventh, MED. Eighth, external will always preferred over internal. Ninth, IGP cost to reach next hop, if that is also same. Tenth, it will compare, tell me, ABGP peering, then router ID, and finally neighbor IP. Neighbor IP, that's it. See, if someone asks you that how BGP will define or will elect its best path, and elaborate it in a sequence. This is the sequence in which BGP will define or will select its best path. First, we'll check next hop reachability. Let's say I'm receiving same prefix from two different neighbors. From one neighbor, next hop is reachable. From one neighbor, next hop is not reachable. Then definitely another one will be best. Second, weight. If next hop is reachable via both neighbors, then it will be comparing their weight value. By default, weight is 0, right? By default, weight is 0. Fine. So I was talking about weight. So it will be comparing weight. If weight is equal, then it will be comparing local preference. If election is done based on local preference itself, then it will not go for next attribute, right? Okay. Then self-advertised. If if it was not possible to define best path based on local preference, right? And if it is also not possible to define best path based on self-advertised, then AS path attribute will take place. If AS path attribute is also common, then it will go for origin code. If path selection is already done based on origin code, then it will not go for any next attribute, right? And if origin code is also same, then it will go for MAD. If MAD is also same, then it will go for external, internal. Remember, external will always preferred over internal. You know very well that for eBGP by default its AD value is 20, and for IBGP it is by default 200, right? So that's there. Then ICP goes to reach next hop in case if both of them were either external or internal. Like I'm receiving same prefix from two different neighbors, and from both neighbors I'm receiving that prefix as either external or internal, right? Then based on external internal, it won't be possible to define best path, right? So next attribute will take place, that will be ICP cost to reach next hop. And this is ICP cost, which means that in the background of BGP, if you are running any IGP like such as RAP, ICRP or OSPF, right, then it will be comparing their metric as well to reach next hop of BGP, right? I'll prove all these things, don't worry about that, right? Then in case if IGP cost to reach next hop is same, or in case if you are not running IGP in the background of BGP, right, then of course this attribute will not take place, right? And all these things are actually these things like this, all these 5 things are tiebreakers. These are not path attributes. These are not, these things are not path attributes. These are simply tiebreakers, right? So then eBGP pairing will take place, means oldest peer will take place, right? But only for eBGP, not for IBGP. This thing is there, this is present for IBGP neighbors only, right? And in case if both neighbors are IBGP neighbors, then this like tiebreaker will not take place. This eBGP pairing will not take place. So finally it will be comparing their router IDs, and in some conditions you will see that router ID will also be same. And in case if router ID is also same, then finally it will be comparing their neighbor IP address. Lower neighbor IP address will be preferred, lower router ID will be preferred, lower ICP cost will be preferred, MED lower will be preferred, local preference higher will be preferred, weight higher will be preferred. Although I'll be discussing all these attributes individually in more details. I'll start it from weight. We'll discuss weight in more details. Then I will start local preference. We'll discuss it in more details, right? So I'll be discussing it. Don't worry about that. For now, I just wanted to tell you that how BGP selects its best path. What is the procedure behind path selection in BGP, right? Fine. Then after it, let's talk about for eBGP default AD value is, for IBGP it is, क्यों? See, BGP meant for inter-AS routing, right? So basically BGP meant for inter-AS routing, which means to configure routing in between two different ASs, in between two different organizations, right? Because whenever you will try to combine two different organizations together, then only you will be having huge number of prefixes over there. So to control or to maintain a huge number of prefixes in the routing table, BGP is there, right? So basically BGP meant for inter-AS routing, right? Because you know very well that BGP is the only protocol which can perform intra-AS as well as inter-AS routing. It can perform both inter-AS as well as intra-AS. Fine. Apart from it, now question is that for eBGP we are having AD value 20 and for iBGP we are having 200. What is the reason behind it actually? See, if you are having, let's say this is router 1 and this is router 2, right? And both routers are existing in different organizations. Let's say it is in Idea and this is your Reliance. Both of them are using different ASs, 100, 200. Now they are having connectivity. You configured BGP between them. By mistake, someone configured IGP as well, or EICRP or something like that. So in that case, if mistakenly you configured an IGP between two different ASs, then also BGP must be preferred. Because in case if OSPF is preferred or EICRP is preferred over BGP, then their routing table can be crashed. Of course, it can crash. So BGP must always get preference over any other IGP. That is why in case of eBGP, by default its AD value is what? 20, which is lowest among all IGPs, among all routing protocols. Right? So that is why we are having 20 for eBGP. Now if you talk about iBGP, which means we are talking about same AS, like this is R1, this is R2, this is R3, this is R4, this is R5, you understand? And then you configured IGP, OSPF, and along with that you also configured BGP. So of course, like BGP has slow convergence, and within an AS we don't need to configure. Are you getting my point? We don't need to configure BGP because we are talking about intra-AS now. These all routers are in same AS. Right? So now, of course, over BGP, IGPs should get preference because IGPs are having fast convergence. Are you getting my point? If you have implemented BGP as well as IGPs, then of course IGP should get preference over BGP. Now you could ask me that, okay, then why will we configure BGP and IGP, both of them over there? Sometimes what happens that you are working as a transit AS or something like that. So your prefix was received on R1 from eBGP neighbor, then again you are having another eBGP neighbor, you wanna forward that prefix, you received from one eBGP neighbor, then you wanna forward that prefix towards another eBGP neighbor as well. In that case, you have two options: either configure OSPF here. If you configure OSPF, then you have to perform redistribution over there, right? From BGP into OSPF and vice versa, from OSPF back into BGP, and that is never recommended. It is never recommended to perform redistribution between BGP and IGPs, right? However, in some scenarios you will definitely find redistribution in between BGP and IGPs, but it is never recommended, right? So what can we do? That for internal communication we can use OSPF, but for those prefixes which are coming from one eBGP neighbor and going towards another eBGP neighbor, for them, for all those prefixes we can use here IBGP, right? So we will require, in some cases you will require to configure IBGP as well as IGP. And even in some cases, if you talk about transit AS, in previous if we talk about that time when we were not having MPLS in the market, at that moment we were having a concept of transit AS, and in future I will teach you this transit AS. I will show you that along with IGPs you will also required to configure IBGP, right? And in that case your router will be receiving prefixes with the help of IGP as well as IBGP, right? Both. Like there will be a concept of transit AS. In that transit AS I will show you that okay, prefix is coming with the help of IBGP as well as it is also received with the help of IGPs. So of course in that case it must preferred only IGP, but that prefix should be available in IBGP as well, so that it can forward that prefix to another BGP neighbor and we will not require to perform redistribution. Are you getting my point? So in that condition, of course, IGP should get preference over BGP due to convergence, right? So within a same AS, IGPs should get preference over IBGP. That is why for IBGP by default they configured their AD, they defined its default AD value as 200, which is highest one among all IGPs. Right? Fine. BGP is the only protocol which can form neighborship with adjacent devices as well as non-adjacent devices. BGP is the only protocol which can form neighborship with adjacent or non-adjacent devices. Now you can ask me, or you could ask me that okay, in OSPF also we configured neighborship between R1 and R10, but we configured with the help of tunnel. Here I'm not talking about tunnel interfaces, right? Here in BGP, the only thing which is required is just to have reachability. Doesn't matter whether neighbor is on same subnet or on different subnet, is in same AS or in different AS, BGP can easily form neighborship. That is why we are calling it as a inter-AS routing protocol.
If we are creating a tunnel, then TTL will be 1.
Of course, because whenever traffic will go through the tunnel interface, again it will add another IP header onto that, and at that moment its TTL will be 255. So it will not drop by transit devices in transit. But in actual IP header it will be 1. In OSPF it is 1, in EIGRP it is always 2. Fine. So if we talk about BGP, it supports classless prefixes, classful both, contiguous, discontiguous both, and supports authentication, that is only MD5, and it supports your summarization, and we can call it what? Aggregation, right? Here we will be calling it aggregation. So here we can configure authentication, aggregation both. So basic tasks are same whether you are configuring IGPs or BGP, like route filtering, authentication, aggregation, right? So all these things will still remain in BGP. After it, in BGP, let's start now once again BGP path attributes, and I will start it from wait. Remember that wait is a Cisco proprietary attribute. So if you are using, if you are having box from Juniper, then you cannot configure, you cannot implement wait over there for BGP best, for BGP path selection, right? So this is Cisco proprietary. Second, for directly connected, default wait values, let me show you default wait values. For directly connected, it is by default 32768 for directly connected prefixes, right? Or for self-advertised prefixes. For received, whether they are received from IBGP or EBGP doesn't matter, but it will be 0. Higher weight will always preferred. Higher weight will always preferred. Right? So now you can also manipulate path selection in BGP by modifying weight value as well, but by default it will be same 0 for received prefixes, right? So in case, like for an example, this is router 1, this is router 2, this is router 3, and R1 is having neighborship with both of them, and one same prefix is coming from both neighbors, like 10.1.1.0/24 is coming from R2, and also R1 is receiving the same prefix coming from R3. So weight will be by default 0, same. So based on weight, it won't be possible for R1 to define its best path. So next attribute that it will compare will be local preference, right? So if we talk about local, and one more thing, weight will never be carry forward within BGP updates. If you talk about weight, will never be carry forward within BGP updates, either to IBGP neighbor or EBGP neighbor. Weight is locally significant. Weight value will never be carry forward within BGP updates, whether BGP updates are going towards IBGP or EBGP. Right? So now let's talk about local preference. Local preference is a well-known discretionary attribute, right? Well-known discretionary attribute, local preference. Well-known discretionary attribute. What does it mean? Sometimes it will be carry forward in BGP updates and sometimes it will not be carry forward in BGP updates. So remember, whenever update will go towards IBGP neighbor, whenever updates will go towards IBGP neighbor, then it will always carry forward this local preference value in updates, within the updates. So if updates are going towards IBGP neighbor, then local preference will always be included in BGP updates. But in case if updates are going towards eBGP neighbor, remember that you will never, BGP will never include local preference in BGP updates if they are going towards eBGP neighbor. That's what I told you before, that what is the meaning by discretionary? Sometimes they will be part of BGP updates and sometimes they will not be part of BGP updates. So remember, local preference cannot cross its AS boundary, right? But within an AS, it will always be carried forward within BGP updates. So it does not have local significant. It is not locally significant, unlike weight. Right? And by default, local preference is 100. Default local preference is 100. Higher will always preferred. Higher will always preferred. And it is not Cisco proprietary, right? It is an open standard attribute. And also it does not have locally significance. It is, it will be carried forward within BGP updates, right? So if you modify local preference on one device, which means that it can affect other routers path selection as well, right? And we will be doing that actually. That is why we will be using this local preference. And in production environment, we mostly use this local preference for path selection manipulation. Let's say local preference is also same. Either we are receiving prefixes from two different eBGP neighbors, then local preference will not come along with BGP updates. By default, it will be considered 100. And even if we are receiving same prefix from two different IBGP neighbors, then also default local preference will be 100. Fine. Then after, it will compare self-originated. Forget about that. Let's talk about AS path. So remember, AS path attribute is a well-known mandatory attribute. Well-known mandatory. So whether your updates are going towards IBGP neighbor or eBGP neighbor, they will always be carry forward. This attribute will always carry forward within BGP updates. This AS path attribute will always include AS path list. AS path list along with prefixes, along with NLRI, network layer reachability information. So you know very well that whenever, let's say this is router 1, this is router 2, this is router 3, this is router 4. Let's say there is a prefix 10.1.1.0/24. R1 is running AS 100, R2 is running 200, 300, 400, right? There is a rule that whenever BGP will give an update to its eBGP neighbor, then it will always prepend its AS on to outgoing updates. On to outgoing updates. Remember that whenever BGP will give an update to its eBGP neighbor, then it will always prepend its own AS in its outgoing updates. So whenever this R1 will give this update to R2, it will say that okay, if you want to reach 10.1.0/24, then you have to cross AS. I mean, inside the AS path list, it will be having AS 100. When R2 will give this to R3, then it will give it to R3 in this manner that if you want to reach it, then you have to cross AS 20 and 10. In this way, it is prepending. See, there are two things: prepending, appending. Prepending means it will add it on the top. Appending.
Prepending means
Okay. What is? I mean, it is something like that. If you are doing prependation, then your originating AS will be rightmost AS in prependation, right? Because it is performing prependation, right? So originating AS will always be your, I mean, if someone asks you that okay, what is the originating AS for this prefix, so you will be looking at the rightmost AS in AS path list. So here you can see that rightmost AS is 10, which means that this prefix was originated by AS 10. What?
100. Yes.
Okay, 100. Okay, make it 100, 200. Right? Then similarly, R3 will be giving this update to R4 that if you want to reach 10.1.1.0/24, then you have to cross 300, 200, and then 100. Right? So let's say we are receiving same prefix from two different neighbors, then it will count total number of ASs available in their AS path list via both neighbors. A path by which we can reach destination by crossing less number of ASs will be preferred or will be best. A path with lower number of ASs will be preferred. But what if you are receiving same prefix from two different neighbors with same number of ASs inside AS path list? Again, you won't be able, or your device won't be able to perform path selection based on AS path attribute. Right? So remember that whenever BGP will give an update to its eBGP neighbor, it will always perform AS path prependation. But if it is giving an update to its iBGP neighbor, then it will never perform AS path prependation. Never ever. If it is giving an update to its iBGP neighbor. I'll let you know that what is the reason behind it. What is the technical reason behind it, right? Because there are some technical things behind these, behind all these things. Fine. Then after it, origin code. If AS path list is common via both neighbors, right? Then it will be comparing origin code. Origin code is again well-known mandatory attribute, and in it we are having three different codes actually. I, E, question mark, I, IGP, E, EGP, question mark, incomplete. IGP here means BGP, actual BGP. EGP means actual EGP. Incomplete means redistributed. And in BGP we are having both of them, iBGP, whether it is iBGP. Remember that if you are advertising anything with using network command in BGP, its default origin code will be I. Remember that whenever you will advertise anything in BGP with using network command, by default its origin code will always be I. And here do not think that this IGP means that actual IGP. No, this is the only point, or this is the only thing where IGP means actual in actual BGP. Otherwise, in all other conditions, IGP means like RAP, EICRP, and OSPF, right? But in case of origin code only, IGP means BGP. That you advertised prefixes in BGP with the help of network command. Right? And remember, this is the sequence. I will always prefer over E, E will always prefer over question mark. And remember, if you redistribute anything into BGP, by default its origin code will be question mark. E, you will never ever get it, because it was it is a older technology, EGP, and you nowadays you will never ever get this EGP, right? Yes, in some NAPs might be you can get this EGP. Any problem? So I will always preferred over E, E will always preferred over question mark. Let's say from both neighbors prefixes are coming with same origin code, whether it is I or E or question mark. It is same from via both neighbors, right? So based on origin code, it won't be possible for router to select its best path. After origin code, it will be comparing MED. Default it is 0, and by default it won't give any MED value to its EBGP neighbor, right? And lower will be preferred. In other words, you can also call it metric, and lower will always be preferred. Lower MED will always be preferred, right? Rest we'll discuss tomorrow, and tomorrow you will come at 3 o'clock. सभी का ऑफ होगा, जिनका नहीं है एक दिन वीडियो देख लेना.
सर ऑलवेज संडे
हाँ जी,
संडे भी 3 o'clock.
हाँ अगर आओगे तो. वैसे